So today we have a really cool panel to talk about cybersecurity and big data science in research and education. And so actually you've heard from our three speakers today. Ina will be speaking, as well as Jay Yang and Richard Biever. And so perhaps we can do ladies first. And Ina, would you like to present first? Is that okay? Tell us a little bit about where you're coming from, the work you do at the Research SOC, and then how this might apply to the community.
Sounds good. Let me share my screen.
Sure. So they're each going to present for 5 or 10 minutes, and then we're going to have an open panel. So feel free to put your questions into the chat, but then we'll also have an open panel discussion. Looks great. Thank you.
All right. So I said that I'm from Indiana University, but I'm a co-PI on the Research SOC project, which is directed from Indiana University. So I'll say a few words about the project itself. So it's a big project and it has multiple objectives. And the main one is to provide operational security services for NSF scientific cyber infrastructure, but also part of that, and Richard Biever is actually a collaborator on the project as well. So we'll work together. Yeah. So the two other objectives is to build the threat intelligence network and communities of practice and outreach to higher education professionals in information security and cybersecurity. But the part that I am involved in, and I'm actually the director for researcher engagement, this is focusing on enabling cybersecurity research, and particularly doing that through providing access to operational security data. So this is what we're trying to do, and how we're doing that. We're trying to learn about researchers' needs for data and tools, researchers who do cybersecurity research. And through doing that, we are building a secure environment to access the data. And as you know, operational security data has a lot of sensitivities, and pretty much no one likes to share this type of data. So one of the ways to address this sort of resistance and to address many concerns that exist around this type of data is to have a secure environment where people can analyze this type of data, but they can't take the data out. So they can only work with aggregated results. And as part of that effort, we also want to curate and organize heterogeneous data, especially if it's coming from different organizations, different types of clients, different institutions. And of course, we want to create awareness of data and its potential. So this is part of my goals, is to participate in building this community and bringing together security analysts, researchers, and other people who are interested in sharing data and working with this data, but also building tools and kind of growing this community. So the secure environment that we're building, and I will not go into the details of the architecture, but this is basically what we're doing. We're calling it an enclave, and we've developed a prototype essentially. So it's, the main component is that there are sort of 3 virtual hosts, and one of them is where the data is coming in and is being stored, and the middle one, that's called the Windows host, is that the users can access to through what we call Bastion host, and so they are configured so that on one part data is coming in and can be organized in a specific way, but then when users are accessing it, they cannot take it out, right? All the ports and other types of configuration, it protects data from download. So then to enable, the research, we need the middle part, we need a flexible environment, and that's why we're learning about researchers' needs, what kind of tools they will be working with, how they will be processing this type of data, et cetera. We're also trying to provide access to various types of data and masking the most secure parts. So even though it's a secure enclave, our security team still thinks that this is not allowable to share raw data. So it's still, masking and sanitization is still a big component of this effort. But then we think with some tools that we've developed, some data like vulnerability scans, for example, could be shared outside of the enclave, but some data will still be staying within the enclave strictly. So what kind of data is staying in the enclave? So far, it is Zeek network monitoring data. And you see that, we've focused on sort of these 5 fields that were, because the Zeek log data, it has tons of information. And it's interesting that once we started working with the prototype, we haven't really considered the amount of resources that it would take to provide access to this data. So we ran out of resources pretty quickly, particularly storage and compute. So then we had to limit the amount of data that we're working with for prototyping purposes. And so currently it's the destination IP and port network transport protocol and the source IP and port. So this is a limited amount of data. I hope it still is useful for research purposes. But then, so the access that we provide to this data is currently done through Kibana that allows to work with data in various ways, also do some interesting visualizations. So this is the dashboard that you can see. And, it's interesting. I think the timing of this panel is very good because we just basically completed the full pipeline and the prototype is working, and the dashboard that you see, this is the actual data flowing in, which is I'm very proud of that we were able to complete that. And as you can see, the flow, like there's some gaps, for example, for particular days. So this is some troubleshooting that will be happening, and we'll see, what is happening and why. But even with this limited data, like I said, there's some interesting opportunities, the ways you can analyze it and look at the types of destination IPs and sources, and then the types of connections that are being made, and also, the protocols and what kind of traffic is happening. So we're hoping that in the future, we will be able to expand what we call a data catalog, the amount and types of data that is available. But on my end, I also hope that we'll be able to collaborate with more researchers and see what types of data they need, but also work more on sort of the various aspects of data sharing, which I kind of consider a wicked problem, because on one hand, there is a need for real world data, and in cybersecurity communities, seems like people are interested in working with real world operational data, but then getting that data and especially setting up an environment that enables processing and analyzing that data is very difficult, not only on the technical part, because the technical part is like, you see the prototype, we've been able to make it work, but now we're looking into how to turn it into production, going from prototype to production, because then you encounter, like I said, a lot of storage issues, legal issues, policy issues. So we're, in addition to the technical components, we're also developing agreements, and access protocols and everything, like the whole infrastructure around data sharing, that I think there are a lot of kind of thorny questions to talk about.
It's a very difficult problem, which I think is one of the reasons we have this data sharing and cyber infrastructure working group.
Yeah, so I'm happy to be part of it. So yeah, this is a very brief introduction to our projects and to what we're doing, and I'm happy to answer questions later on.
Ina. Yeah, I think this is excellent. Thank you. I think what we'll do is let's have all 3 presentations, so we have a feel for what the landscape looks like. And then we'll go to Q&A and the panel discussion. That'll be great. And so, Richard, why don't we have you go next? Are you ready? Do I see you?
There we go. The obligatory, let me unmute myself. Okay, so let's see here. Make sure this pops up right. Yep, I think that popped up right. Okay, so yeah, I want to talk a little bit about Stinger. Stinger is shared threat intelligence with network gatekeeping and automated response. It's a tortured acronym.
Can I just ask one question? Could you make it?
Yep.
Do you need to have the preview mode? Do you need that, or are you comfortable having just the?
Oh, it showed up the let's see.
Yeah, for those like people like me that we can't see little letters, it's easier if
Is that
it's
better?
not yet.
Did that do
No,
it?
you're still
Right.
showing the presenter, right? Like your view. Your view.
Yeah, hold on. Okay. Let's try this again. Why is this?
I don't know how to give directions and how to fix it. Sorry.
I think the switch display button should be on the top.
Yeah. Yeah, somehow I messed it up. Hold on 1 second.
Sure.
It also doesn't help when I'm running 2 monitors.
You want a little time to do that? We'll have Jay present. You want to play with it or no? Oh, no, you're good.
Let me try it one more time, and then if that doesn't work, then yes.
Okay.
Okay, so we got that. And we've got swap displays. Better?
Oh, you did
or
it.
worse?
Good job.
Okay, good. Yeah,
You
there
won.
you go.
Good job.
Okay, so right, Stinger is something that we developed here to help with threat intelligence. It originally started off with threat intelligence, and like Ina noted, we're partners with Ina and the rest of the Indiana crew and Supercomputing Center on the RSOC project. And really, what we're trying to do here is with Stinger is figure out how to collect threat intelligence, how to use that in automated blocking on our network, and then how we share that with other people. All right, so those are kind of the 4 goals. We do use honeypots on the collection side. I do want to note on this particular slide, we use low and high interaction honeypots. For those that aren't aware, honeypots are vulnerable systems that we just put out on the network. They're designed to be compromised. High interaction means that we allow an attacker to actually connect to the honeypot. They can run some commands, they can do some different things, etc. Before we block them. Low interaction is a type where once they touch the honeypot, we block them, right? And we just assume they're malicious and we don't capture any additional data. The core data that Ina mentioned for Zeek on source IP import, destination IP import, some of the TCP IP information, the type of honeypot that they attach to, that's included in all of our data, regardless if it's a high or a low interaction honeypot. From a sharing perspective, we're using a technology called CIF, Collective Intelligence Framework, to collect the data and then turn around and share it. Right now, we're sharing with, I want to say, a bit over 30 partners. That number's going up as we add additional labs in the RSOC environment. And then we also have the ability to pull the data back via the individual components, whether it's just pulling a feed of data back or pulling data directly from the honeypots. So the biggest thing from our perspective operationally, why do people want to participate? We actually started this approach back in 2014. And that was really starting with just traditional log data that was sitting in a SIM, and which was helpful. But what we were trying to figure out is how can we generate our own threat intelligence, right? With it, because when we talk to vendors, the costs involved in buying threat feeds, et cetera, was so high, it was not actionable. It was usually, running several days behind. And it was not unique to our environment. So that's why we decided to do it ourselves. So we started using honeypots to pull in more data, and that led us in 2017 as we really kind of went live with this. We saw an 85% reduction in our intrusion prevention, our commercial intrusion prevention alerts. That doesn't mean that you stop buying intrusion prevention devices. What that means is it took all of kind of the brute force, the scanning attacks, it took all that off the network, and we were able to see much more interesting kind of attacks showing up in the IPS. And we were sharing about 17,000 unique IP addresses a day at that point. So from purely operational, it's low or no cost. It's very simple to set up and get going. It's got a flexible design. We've developed different types of honeypots for it. Some are open source, some are ones that we've developed. It's an open framework. It removes noise from your network, and more importantly, for this group is it supports research, right? So we've got a body of data that we're collecting. We're working with the RSOC team. Some of this is going to go into that enclave that Ina mentioned. And we've worked with at least 2 researchers on the data that we have. And the latest researcher we worked with at Duke, they were taking the honeypot data and combining it with Zeek data to get kind of that full view of the network traffic and what was happening. So I'm not going to spend a lot of time on this. I did want to point out a couple of data points here really quick so we can move on to Jay and his presentation. But the Stinger threat feeds we find are highly relevant. Over 40% of all the indicators of compromise are new or unique or never seen before. That speaks volumes to me from an operational standpoint of how quickly attackers are cycling through infrastructure to target organizations. Here's the data that kind of shows that roughly 40% of all IP addresses that are collected each day are new. Looking at the threat landscape, we kind of see, what would be somewhat expected. The top country by unique IPs, Vietnam in this particular case. I think we did this slide back over the summer, so it's a few months out of date. But at the time we took the snapshot, Vietnam accounted for 12% of all the unique risky IPs. But then the top country ASNs, Brazil was the top country for the number of risky ASNs or network owners. So it kind of starts giving you an idea of where the threats are coming from, both from a network space as well as a geographic space. This is an example that just kind of shows, in this case, this is the Duke example. If we compare on the right side, the overall threat landscape, you kind of see that China's up there in the top right quadrant because when we add everything together. But in Duke's case, at the time we took the snapshot, it was really more of, from a country perspective, Russia and Vietnam. So you start seeing a little bit of variation there, which we thought was fascinating. About 20% of all IP addresses are seen by at least 2 or more partners, with an average time between attacks of, within 24 hours. That's a positive thing to me. That means if we're sharing the data around, as soon as somebody sees something bad, other people are protected. And then from a rich data perspective, much like Ina noted, the thing that we're really interested in is getting beyond just the metadata associated with network connections and into that deeper level. So if you're running kind of the high interaction honeypots, we start, being able to do some, as you can tell here, it's a little on the rudimentary side, but we start getting more information that we can do additional analysis on. So in this case, we start seeing the types of usernames and passwords that attackers are just automatically trying, gives you indication perhaps of what they're interested in. And then we also capture quite a bit of the commands that they're running. So again, it kind of starts speaking to building a profile, if you will, of the types of groups and the commands that people are running. So we're pretty excited about this. We think that's got some value here potentially, and we'd love to continue working with the community on it. And if you're interested, obviously, more than happy to talk to you, and you can also visit our website and happy to help out where we can. So I will stop there so Jay can go.
That's wonderful. Thank you, Richard. And Jay Yang, since we have multiple Jays, if you'd like to start sharing your screen. And Richard, it's been so cool watching you grow up, not you, I mean, Stinger, from when you first got the award and to how much impact you're having. And it's wonderful. Thank you for how you want to continue, your broader impact and working with more people to add more value, gather more data and add more value. That's wonderful. So thank you for that too. You and Ina are both doing a wonderful job of already working with a lot of the community, and we want to increase that if we can for everybody. And then Jay, who works in artificial intelligence, machine learning, I think of that as like going even further into the future. So I'm very excited to introduce Jay Yang to talk next.
Thank you, Florence. So I'm not going to present the whole, just this. I think it's easier for me to see all the people's name and here and there. Very nice to hear Ina and Richard's presentation and questions for them already. All right, so I'm a researcher. I work at RIT and been working on AI/ML for kind of understanding, predicting, modeling cyber attacks for quite a long time, 15 years. So I'm going to briefly talk about my research, but really want to connect to this audience in the sense of what is the real problem and what's the real data challenge here, right? So, okay. So today's SOC operation, people use Wireshark, Suricata, Zig. You heard a lot about this already, Steam. Most of these tools really give you a lot of statistical summary of like how many IP addresses come from where. I think that you already just saw Richard showing that. I think ASN, that's one of my questions I'll address a little bit later. So basically see that what kind of threat coming from where and to what kind of servers, really like numbers, like counts. That's the key things to look at. The rich data analysis really relies on people, right? The human expertise. That's the solution and that's the problem. So today that very experienced great analysts will take a lot of time really to get a very rich analysis. What kind of threat, what kind of cyber attack campaign is going on my network. I really like what Richard presented, kind of benchmarking between one university against all the data feeds. I think that's very exciting because I also was trying to do that as well. The bottom line is that if we want to do more than just summarizing percentage of IP address, percentage of port numbers, like summarizing more than basic statistics, we need some help, right? The human analyst, the human cognition is just not there to process millions of alerts, millions of log entries every day, every hour. So how do we do? What can AI/ML data science help? So in our group, we developed 3 prototypes. And some of you already heard from me before talking about ASSERT. More recently, that my student been developing the prototype for HeAT-PATRL and also Clear Road. They like acronyms, right? So I'm going to briefly talk about what they are. Actually, I just added one slide because I think that's very relevant to what Richard said about rich data analysis. So I'm just going to quickly see that some of the example results processing real alerts from either real SOCs or in a like I said, exercise kind of data. So the first one, this is actually processing data from a real SOC operation. Is actually 2020. Yes, 2020, August timeframe. We were looking at using ASSERT to extract different kind of attack behaviors. And this 1, 2, 3, 4, 5 lines representing the volume of alerts, Suricata alerts for each of the 5 different command and control through different services. The blue line, for example, is command and control through domain controllers. The orange one is going through MS SQL and so on and so forth. What's interesting that during that time frame, you see the blue that go up and down very periodically. That actually seems like a real situation, probably due to a misconfiguration, something that continues going on for the network. Meanwhile, that you see that the orange was in the order of 10 and 100. The y-axis is the volume in the logarithmic scale. So before August 18, 2020, it was at 10, 100 level, that level of scale. And then suddenly jumped to 10,000, 100,000 kind of level, the MS SQL. We see a lot of command and control through MS SQL at that time frame. I do not have reason behind it. I'm not an operator. I cannot tell you why that's the case. My hypothesis is that that's a time that school starts, the fall semester starts. So there may be something going on with a different configuration or users certainly swarm in, so create a lot of traffic in that area. We do not expect that all of these are malicious. Some of this could be misconfiguration. Some of this may be due to users. Again, the point here is that the AI/ML helps to summarize data in a richer way than easily interpretable by human. Okay, this one is actually, I'm actually move forward to this one. So this one first. So this is a very novel machine learning approach that we developed called PATRL. PATRL stands for pseudo active transfer learning. And the idea here is that, so Richard talked about very rich like data analytics in terms of the signatures in the alerts or some of the log, the sentences, you have CVDs. You need to kind of really analyze what's actually happening for a given log entry. So we have developed a method to help analysts to interpret those cryptic analytics to understand the potential intended consequence of the adversary. So we've done that, and we demonstrate with our more theoretical result that we can translate Suricata alert signatures into what we call attack intent stage by reference to MITRE's attack framework, right? Using that, we can do even more. So this is the slide that I was showing you earlier. I need to go into presentation mode so you can see the animation. So idea here that we given a lot of data. This actually come from collegiate penetration testing competition. So we collect the data. We're looking at for particular IOCs, what are the previous steps that lead to the IOC? So if we use the previous patrol thing and we interpret the data, we're able to see how the prior steps from recon scanning, data exfiltration, all the way to have a code red alert that happening at the end. So about spending over a few hours during the competition, we can reconstruct the attack campaign for that purpose. All right, so the last one is Gordon was doing, the previous work is done by Steve, and this was done by Gordon. So Gordon is developed pattern mining algorithm, again, to help analysts interpreting what's happening. So he processed both the real world data and the CPT data. What he has found is that if you look at the code red, when people execute code red, what might come before and after with a pattern, right? Be the odds, be the statistical odds that this is happening. We have found that there are two ways to see the code red. One is with alerts before and after in milliseconds. You can see the top portion of it is in milliseconds. And the bottom is a different way code red is being seen. And the attack actions before and after are more in the order of 30 seconds. These orders of magnitude differences. So we can conclude that, hey, there are two very common ways people use code red and then provide that insight, that threat intelligence to analysts. Maybe in the future, when we see this kind of root access over here, very soon we're going to see code red. Well, if you see this, then it's going to be another 30 seconds. Not that millisecond, 30 seconds is very different for human, but probably very different for machines, right? So we have published these papers. Essentially, that my main point I want to get through is that working with the real SOCs to getting, where's my slide just disappeared on me. I'm going to find my slide very quickly. My slide disappeared on my screen.
We actually saw it when you did it.
You saw it?
We don't see it. We did.
Oh, it changed my I got it, no problem.
My system would just try to do something to me too. Maybe
No
there's
problem.
a bug going around.
It's right here. No, it's right here. Okay. So yeah, so thank you for listening. I think that the main point I want to convey is that researcher does get a lot of benefit to understand the true challenges in data. Here we're presenting the results using this unsupervised non-labeled data, trying to gain insights on how we can help analysts really looking at the rich data kind of analytics, right? It's not just summarizing IP address. It's not just about the port numbers, but also a little bit more about what kind of attacks are happening, what kind of earlier action lead to later actions, that kind of thing. So thank you. I think hopefully I didn't occupy too much time. I'd love to hear your thoughts, ideas, and comments.
This was excellent. You're all doing such valuable work and very impactful and very complimentary. So great job. Thank you all for presenting. And so I always have questions, but I don't want to go first. I want the community to ask questions. So is there anyone who has a question or a comment or a different point of view? We're very open and inclusive here when it comes to thinking. Christine, I think you have your hand up.
Yeah, I've got maybe 1.5 questions. We'll see. So back on Stinger, and I think this probably will expose more of my outdated understanding about the work of the security teams. But when you're looking at, identifying different IP addresses, how do you sift out, or does it matter people are doing IP spoofing? Like, does it help if you're blocking a whole bunch of people who that's not really where they are? Or anyway, tell me more.
Yeah, so no, that's a good question. So part of setting this up from a technical implementation is getting your safe listing right. And so one of the things that we spend a lot of time on is how we safe list IP ranges that Duke deals with, whether they're cloud providers, et cetera. Now, from an IP spoofing perspective, you know, sure, but we also work pretty closely with the networking team to enable some of the anti-spoofing controls that are on the external routers, things like that. So hopefully by the time it gets to the honeypot, that's not an issue. I will tell you, I haven't seen, we haven't had a false positive, okay, which is a good thing. We used to have false positives all the time with SSH connections coming through the IPS. And B, the IP spoofing isn't what we've run into. We have run into the situation occasionally where Google or Microsoft just, you know, slaps a new subnet in for a little while, and we've had to go adjust for that.
Thanks. And then my follow-up question is, I think both for Richard and Jay. So in the chat, well, Jay mentioned, and then Richard followed up in the chat talking about putting together security analysts with data analysts. And I was wondering if one or both of you could say more about models that you've seen working, because I think I'd really like to hear more about that too.
Jay, you want to go with that?
Sure, I can talk a little bit about it. If I understand your question correctly, Christine, you're talking about the analysis of the overall kind of campaign from beginning to the end, right?
Well, and specifically, I'm wondering if you're able to work across organizational barriers. You know, our main security team is in central IT. The San Diego Supercomputer Center, we collaborate with them from time to time, but it can be very difficult to, even at the same university, to work together.
Right. I think that Richard probably have a lot of insights on that. So I can tell you that I echo Richard's comment in his presentation about they're looking at the threat intelligence from cross-organization and comparing that against that. And in that chart is dream for me. I'm looking at how we can get that kind of data to do it. How to overcome that, Christine? I don't know the answer to that, but I do have a vision, right? My vision is that if we can somehow find a way to summarize the data in a way, individual organization or individual subgroup organization doesn't feel as sensitive, right? So if we summarize in a way, so for example, Richard, you mentioned about, if I remember correctly, Vietnam and Russia versus China. If that kind of information is not as sensitive, people are feeling okay with that, that's great. And likewise, I just share about, for example, command and control through MS SQL, command and control through domain controllers. Is that something that an organization will be concerned? What if I share it in a way that's aggregate, right? So out of 20 organizations I work with, these are top 5. And their aggregates, it's not necessarily from 1 or 2 organizations. So for me, if we can convince the organizations that I'm sharing with you the aggregate data, not your IP address, not your URLs, not the specific CVEs you have, hopefully that will help alleviate the concern.
Yeah, because you raised 2 really good points here, both of you. The first is, let me take Jay, the point you just made first. So my philosophy is, I don't care who knows what IP addresses, what domain names are attacking Duke. I don't care. I don't care if they know what ports they're attacking over, right? I do care if, about publicizing, oh, this account was compromised, the system was compromised, right? I care about the internal view of that. So to me, and this kind of goes back to in the security space, whether it's because of legal compliance or paranoid security officers, we are not doing a good enough job sharing the information like Jay just described. We need to do more of that. And we need to provide, here are the IOCs and the TTPs that we have seen hit us. If you don't want attribution to your organization, great. I totally understand that, but there is benefit to sharing that information. So that's one comment. And as far as the data analysts, I will tell you, so I was somewhat lucky in this regard twice. The first is we bought a log analysis system about 7-8 years ago. We bought Splunk. Right around that time, I hired a new security engineer. In the past 7 years, I can't get him out of Splunk, right? He lives in Splunk, he loves it, and he's built a lot of our operational dashboards, but these are point in time dashboards. We built a data analytics team inside of central IT with data scientists, data analysts, data engineers. And I pay for part of a person. Actually, she works on the RSOC project, Gagandeep Kaur, and she lives in both worlds. And so she and Eric, our Splunk guy, they can talk the same language, and she's doing these deeper level analyses. The data that we showed here, that's a result of her work, and that's just kind of scratching the surface. So I think it's important to have, and what we've seen is the value of having data scientists and data analytics that understand how to work with the data, but you're pairing them up with the people that understand what you're looking for.
Thanks, that was really interesting.
Just to add to that, the point about successful models, I think there's three sort of related points. One is in sharing data, the understanding that the data will be shared needs to be at the beginning of the conversation and not an afterthought, because this is what we saw. If you start with that, then you can work with organizations, even if they're very uncomfortable sharing their data, right? There is a process, and then agreements and things like that. If it's an afterthought, it's very hard to do that. But then, then the second point, sort of related to that, is to think through the agreements and being transparent, right? That's another part, that everything that goes into documentation, both parties kind of think about that, because I think the security folks and the data scientists on the research side, they have different objectives, right? So aligning those objectives is another component, which doesn't happen if you don't think about it from the beginning. But another aspect of it, I think, and partially what we're doing, it's bringing students in there and not sort of established data scientists. Again, it's harder to start with when people already have their frameworks and set minds. But the students who are hopefully more flexible and bringing them into the teams, I think that also opens up opportunities a little bit and creates more success.
Thank you so much for bringing that up, because you're absolutely right. One group's trying to publish papers and find tweaks to algorithms, and the other one's trying to keep a network secure. There's a bit
and they need very immediate reactions.
Yeah.
Yeah.
Very interesting. The cultural phenomenon, the human condition, as we say. Whenever we get to we'd say, "What about the humans?" And sometimes people look at you like, "What?" Especially our technical, group. And it's very important to think of the human condition. So I think the next hand up was Matthew Wang, and then Jim Wilkenbush. Matt.
Hi, everyone. Thanks for 3 great presentations. Ina, I'm sorry I walked in the middle of your presentation, so I apologize if you actually covered what I'm about to ask. But I'd like to ask this actually across the presenters. Delighted to hear. I don't spend my time in security full time, but I do spend my time building ontologies, and so I'm going to push my agenda. I'm delighted to hear about the framework for sharing information. And as I was listening to these talks, I went and Googled ontologies for cybersecurity, and this idea of having knowledge graphs and perhaps building shared knowledge graphs around this. That also it would potentially include a knowledge graphs of models that represent how people are attacking, right? So we could be sharing not just the data, but the models as well. And I'm wondering is there an appetite for that, and what that might look like in each of your projects?
Well, I can say about our projects, since our main goal is to share operational data, whatever is being collected from clients that use research SOC operational security services. So we are focused on data. But looking into the future, I agree with you. I think it's important to share models, and I hope that as part of our future work, we would encourage researchers who work with our data share their work and hopefully contribute to model sharing and tools and software sharing as well.
I'll comment a little bit. So in the security academic kind of research environment, even industry, there's an increasing trend to make both the data and model being shared. We call it artifacts. And so there are indeed an increasing number of researchers doing that. Of course, not everyone yet. The challenges I see is that the current majority of the machine learning AI work is in the realm of supervised learning, which I personally do not agree. It's my opinion. You don't need to agree with me, but I personally do not agree that that's very useful for cybersecurity. In some cases they are, but in most cases I don't think they are, simply because label data doesn't really cannot exist in the real-time operation, like updated, unless you can afford to hire someone who label data for you every single hour and day, which I don't think is possible. So that's my opinion. My view going forward in the future is that publishing meaning disseminating model data, as well as that findings, right? So I've been hoping to get a project funded to really have like creating a gateway where we can share 100 institutions attack models, attack behaviors online. So as soon, and it based on real-time data, right? So it's aggregates. So if I see something that's really start rising from like the orange line I talk about, if the orange line start occurring not just in one organization, but multiple organizations around the same time, whether it's misconfiguration because Microsoft did an update or because there's a malicious campaign going on, doesn't matter, then everyone sees that, then do something about it. Instead of you try to decipher, hey, what happened on my log versus what happened in your log, right? So that will be my hope in the future, not just sharing the data and model, but also sharing the insights that's obtained based on real data.
And Richard, did you have anything to add? I think Matt was asking across the board.
I think Jay and Nina covered it pretty well. I guess from an,
Okay.
kind of coming at this from an operational perspective, we're interested in actionable information. And so part of the challenge is, right, one of the things that we enjoy doing is working with the research community on the model piece, because we recognize we need actionable information, but it's also, you look at how fast the speeds are going right now with network traffic, et cetera, then we have to make decisions faster and better. So that's my only kind of observation. Not super helpful, but just recognizing the need there.
Yeah, and Carolyn put in the chat, cyber needs a data interoperability standard.
Thank you all.
So
Very
I
good.
just spent the last week for work looking into FHIR, which is a interoperability standard for healthcare data. And I'm like, wow. And they're talking about all the problems. I'm like, we have exactly these same problems. There's too many tools and too much data, and we can't speak the same language. And it's just so much work to get all this data together into some sort of reasonable format. So I was like, we need this for cyber.
It's a very good point. I'm really glad you brought that up. I actually worked on trust, identity, privacy, protection, safety, and security standards for clinical IoT, with IEEE. I lead a global working group on that. And so FHIR is a part of what there is, but there are still holes there too that we're working on at the interoperability level for all these new devices. So we should talk about that a little bit later, but I want to let Jim Wilgenbush ask his question, if that's okay.
Thanks, Florence. And this is kind of echoing something that was brought up before, but I just really wanted the panelists to maybe give some more specific examples. And that is, when you talk about researchers in the context of this talk that the talks that you gave, which were great, by the way, really appreciated them. You're really kind of talking about cyber security researchers, and it kind of causes my mind to bend a little bit, because I'm thinking of sort of domain researchers often at the same time. And I wonder to what extent, here I am, running a large center with a huge number of projects and dealing with compliance across, a broad spectrum like a lot of us. I wonder, to what extent do your teams purposefully interface with some of these domain areas, to domain science areas, to sort of infuse the application of this work into some of the infrastructures that you support on campus. I know you alluded to some of that, but I was kind of hoping maybe you could just highlight some examples where your teams are doing, really sort of moving some of this innovative work, into your active infrastructure, your current infrastructure.
Maybe I'll address a little bit, Jim. So I was, thanks to Florence, I was one of the TTP early people on the Trust CI. So I actually work with OmniSoc and try to help deploy that. I will tell you that that's, again, the dream of me, right? With the gateway I talked about earlier, but also all the prototype we develop can be used. But it takes time. It takes time and effort. Being academic as a researcher, as a professor, students, right? So for example, my 2 students right now, they're presenting a conference. They're trying to produce acceptable results that can be published so that they can get their PhDs or masters or undergrad, whatever. At the same time, they put down their code that can be put in GitHub, GitLab, and things like that. But those codes are still very challenging to be download, hit play. So my Mac, right? So I can download it, hit, install, everything works well magically. It is very challenging to do that. I love to work with Richard. I can see from his presentation, there are a few things that his team could experiment with me. I'll really follow up with him on that. Ina, the type of data I'll follow up with you a little bit more about, and maybe that's one of the questions I'll ask you, but with IP and port, there are certain things can be done, but also there are things may not be able to get done. So I'm curious whether it's something that I can help you to make your operational easier so that you can share more data by alleviating concerns. So yes, Jim, I really like your question because I think that should be every single researcher, whether it's cybersecurity researcher or some other researchers goal, right? The research should have some impact, whether it's immediate impact or futuristic impact. I think that's important for researchers.
And there may be an opportunity for us to think about some things we could do in the future. That's one of the things. That's why we're having the cybersecurity discussion now. We had another one in April that Jay helped lead for us across the community with the Data Sharing and Cyber Infrastructure Working Group. And Caroline and Matt and others, a number of you were there too. Maybe there's something we should put together regarding the domain scientists, the cybersecurity experts and researchers and data scientists. Maybe we should try to put together a workshop like that. At this point, it might have to be virtual. NSF said you can ask for permission to use money in person, but people have to be allowed to go. So it's kind of complicated. But have we all done that as a team yet? No?
Well, one thing, yeah, I mean, I think that's a great idea. One thing I would like to point out on that, because I do think this is a great question and a challenge, Jim. So I worked at Georgia Tech before coming to Duke, and Georgia Tech at the time had this massive, I mean, obviously you've got GTRC there, you've got the College of Computing there. They're doing a lot of really, I mean, back then and even now, they're doing some very cool things in the cybersecurity space. What I would say is, since being at Duke, we actually have found what I like is our CIO has really pushed central IT involvement in the research space and what we call a co-curricular space, things like that, working with students. So, two examples. We are working with a professor at Duke right now on a grant-funded project that's going to involving building anomaly detection models, and we're using the honeypot data along with the Zeek data to help prove out the modeling for it. I'm interested in that because, like I said, if it improves the effectiveness and the efficiency of it, that's less work my team has to do. But it has to be actionable and it has to be applied, I guess, maybe is the right word to say. So very, very interested in that. We also worked with another researcher on an initial DoD grant that ended up making it to phase 2, but there is that interest there. So I think that the cool thing that, kind of the blessing and curse is that the operational teams at the schools, right, the security teams, they've got the data. they're interested in talking about the data, but they're working to try to solve problems, to stop the bad guys, to put out the fires, et cetera. And so how you match that up with domain expertise, if you can do that and make life better and advance research at the same time, that to me is a win. And why aren't we doing that?
Yeah, you hit it right on the head, Richard. Those are the kind of examples I'm looking for, because I mean, I'm the first one to respect, you know, really sort of leading edge research, and that sometimes it needs to be so far ahead of the application that it's not practical in many instances. But, you know, there are real opportunities in this space to bring it closer, where there can be some win-wins. And just curious about sort of how that works, because I'm looking for those at the U. We have lots of opportunities where, you know, we can bring those to my own university. And it usually, the way it usually works is, you know, we could say, hey, let's look at Duke as a model. They've done some things that we could actually sort of inspire some people to see tangible ways in which things that aren't necessarily in our typical bucket or toolbox, you know, could be implemented.
So maybe as a follow-on, I'm sorry, go ahead.
Well, Jim, I'm curious, when you say domain scientists, what kind of domains do you have in mind? Because
yeah, that's great. Yeah, good question. So, like, I mean, I know that you're working in a lot of sort of health sciences, or with many health sciences, in terms of probably the data that I saw just in the brief overview that you gave. But that's one area. But then there's others where, you know, obviously CMMC around CUI, you know, type.
What is that?
The CUI.
CMMC, CUI, yeah. I'm
So
just not
CUI
familiar
is controlled unclassified information.
Oh, okay.
So that's another, like, a bunch of different types of labeled data that have different risks associated with them.
Okay.
And then CMMC is a new certification process that sort of is, I mean, it's very prescriptive and not, it's very vague and wants to be very prescriptive, I should say. So those are classes of things that come through my office all the time, and that we have to address, and the sort of willingness of people to step outside very standard, rigid approaches are limited by those.
So you're talking about those groups sharing their data and not them using operational security data. Is that correct? Because I think I didn't really understand. So, for example, you know, we're providing access to operational security data, and I mean, I'm curious to learn if there are domain scientists who would be interested in that type of data, but I'm not sure they would be.
Kind of talking about different things. So this is like protecting the data that your
right.
Operational data is
so broader than security data, but using a secure environment to protect those types of data. Is that what you're talking about? So I think our Enclave solution is generic, and it could be used, for any type of data that needs protection. I have another project that actually we're working with libraries and creating an environment for accessing digital collections in libraries. They're protected with copyright, and you can't download those and work with those. And I think there are various Enclave solutions. In our experience, it's kind of a very customized process to provide access to restricted data. So, you know, there's no like plug and play, you know, take, install and work with it. And partially because you have to work with various institutional setups and the way institutions control access to networks, access to physical versus virtual resources, and all that. So we have to kind of work through all these hurdles to figure out what the right configuration is.